All right, so I told you guys I'd do a short video to finish up what we did not finish in class. So we had used StatCrunch for a 90% confidence interval for mu in example 4. Now we're being asked to construct a 98% confidence interval for mu. Make sure that you read super carefully because now our sample size is back to 40. So again, the purpose of questions B and C are to compare from the original A, if I change the sample size, what happened? Now we're looking at if I keep the sample size the same as the original, but I change the confidence level, what is going to happen? So in StatCrunch, and I had kind of rushed through the bottom, so remember that if you're using StatCrunch, you should show what you typed in. So I'm going to go over to my StatCrunch here. I'm going to get rid of this because that was from the last problems. So I'm going to go into Stat, excuse me. I'm going to go into Stat and go to T-Stats. There we are, and then one sample. We're still with summary. So here's where I start writing down what I typed in. So when I switch back over to the paper, you'll be able to see what I wrote down, but I'm writing down X bar equals 35.1, and I'm writing down S equals 8.7, and then I'm writing down N equals 40, and then CI 0.98. So type that in now, 35.1 and 8.7, sample size 40, choose confidence interval, in this case 0.98 for 98%, and then click compute. Drag this over so you can see it. So here is the lower limit, 31.76, and then on my upper limit I've got 38.44. So if I switch back over here, here is everything I typed in for StatCrunch, and the answer I got was the interval 31.76 to 38.44. Then the follow-up question, how does increasing the confidence level affect the margin of error? Now again, we are comparing this to what we did in part A. So in this case, increasing the confidence, so increased confidence leads to, so this interval is wider, right? It goes further down below and further up above, which means it had to have a higher margin of error. So higher or increased margin of error is what happens because it's more difficult to be more confident. So in order to cast our net and be that confident that it's going to contain the true population mean, our net is going to have to be wider. So hopefully that makes sense there. If the population size is 18, what conditions must be met to compute the confidence interval? So if the sample size is 18, that doesn't meet, if we look at our requirements here, that does not meet our large sample requirements. So we need to know that the population is normally distributed, is what we would need to have on part D. So what conditions must be met? The population must be approximately normally distributed. And if you were more specific about that, you know, and you talked about the outliers and QQ plot, that's fine. That's just more specific way of saying that we're meeting this requirement. All right, the last one. Following data represent the age in weeks at which babies first crawl based on a survey of 12 mothers conducted by Essential Baby. Use either option 1 or option 2 to verify the requirements for constructing a confidence interval for mu are satisfied. So the reason why we have to choose option 1 or option 2 here is because our sample size is less than 30. So let me load this data into StatCrunch here. All right, so I've got all of those data pieces. I'm double checking them here just to make sure I didn't make a typo, because that would be tragic. So I typed in all the data. So in order to use option 1 or option 2, the first thing I'm going to do is look at what the requirements are. So I could, for option 1, look at a normal probability plot and a box plot to check for outliers. So I can go to graph and QQ plot, choose age in weeks, and I want to add the correlation statistic, normal quantiles. So these are the same things we did in section 7.3. And when I do that, I can see that it gives me my correlation as 0.982. Now remember, if it fails something, you don't have to check the next part. So I would always want to make sure, okay, well, is this meeting option 1? So in order to have that approximately normal, I need to compare to the critical value. So I know that R is 0.982. And so the critical value, remember, comes from that table 6, which was on the back of your 7.3 notes. So for n equals 12, it's 0.928. So in this case, R is greater than the critical value. So far it's meeting the options. Now I need to make sure that it doesn't have any outliers. So if I go to graph and I choose box plot, choose that guy. I don't need the labels or anything. You definitely need this checked. The default has it checked because you want to identify outliers. I meant to check the box to make it go the other way, but I can go into edit, draw boxes horizontally. Now it looks normal. And I do not see any asterisks outside the whiskers. So that means that there are no outliers. So I have confirmed. And if you were doing this type of problem in your homework, you would obviously need to put the QQ plot and the box plot in your graphs that you either print or share with me. So this means that option 1 requirement has been met. So if the requirement's been met, then that means that I can go ahead and construct and interpret a 95% confidence interval. So go back again now to my StatCrunch. I'm going to get rid of these since I don't need them anymore. And I am going to go to Stat T-Stats, one sample. This time it's with data because I have the actual data pieces, not a sample mean and sample standard deviation. So I'm going to choose age in weeks. It is a confidence interval, and 0.95 is the right one this time. Notice that it gives you, and I wanted to remind you of all the ways we could do these before, but here it does give you options for doing QQ plots and dot or box plots in there, so that can help you to confirm that option 1 kind of in fewer steps if you would like. So here is my confidence interval. Notice that it also gives me my sample mean in there. So if it were to ask that, we could come up with it. So here's my lower limit. In this case, the original data is 2 whole numbers, so I would round to 1 decimal place. So 31.9, and then this would be 44.6. So I put in, so with data in StatCrunch, and I used 0.95 for my CI, and my answer was 31.9 as the lower bound, 44.6 as the upper bound. And then it asks you to interpret. So the interpretation script was in your previous set of notes, if you need to look back at that. But we would say we are 95% confident that and in this case, mean age at which a baby first crawls is between 31.9 and 44.6 weeks. Sorry, that was cut off a little bit. Move it over so you can see it. And so that follows our same script that we learned about in section 9.1. Hopefully that helps you feel confident about the rest of the practice.